All right, so this is the stack data structure that we're essentially going to go over. But the main thing to remember is that we're going to be covering a lot with it that's applicable to just programming in general when it comes to programming different data structures or different types of applications. A lot of this stuff is immensely fundamental and carries over pretty much everywhere I've seen. Now, I've created a package here called Stack, and that Stack package is going to contain everything we will have regarding the stack. So you'll see there will be multiple files. There won't just be one, and they'll all sort of be encapsulated within this package. Now, the first thing I'm going to create, usually you see me create a class first. The first thing I'm going to create here is something called an interface, and we're going to talk about what that is. Now, it differs from IDE to IDE, but if you go to your package, you'll see an option for an interface with the logo I. So you click that, and since I'm creating a stack, and that's really what we're doing here, we're creating a stack from scratch, I'm going to call it a stack interface. So you might, if let's say you create a linked list, you might call it a linked list interface, or really whatever, right? In this case, we're calling it stack interface. Now, the main idea here is, and I said this to you the other day, I said, well, what is an interface? And the best way to think about it is, how we described a class. We said a class was a blueprint for an object. An interface is a blueprint for a class. And that's really the main thing here. So I'm going to write an interface is a blueprint for a class. And what you really want to remember is that it contains method, and I'm going to capitalize this, it's important, method headers, not method implementation, right? So your interface is not going to implement anything. There won't be any implementive details. There will only be the headers of the methods you want your class to have. A key question is, why do we want an interface? Because if computer science, the subject, if computer science dictates a stack must have, X, Y, Z for its methods, then an interface forces your class to have those methods, or let's say forces your class, which in this case is going to be a stack, it forces your stack to have those methods so that you can't redefine what a stack is. So does it make sense why we might want to have an interface?
Yes.
Okay. And you were going to comment on that?
So interface is like, it's purely like structural, right?
Yeah, it is purely structural. So nothing I have in my interface is going to implement anything. It's just going to be a list. You can think of it like a laundry list. Oh, I want my stack to have this method. I want my stack to have this method, and so forth. So usually what will happen in the real world is, let's say, they want you to build an application. They'll give you an interface for the application. And so that, okay, the application they want has to have these things. And that's sort of like that might be a hand down, like you're handed down an interface, and your program must have, they don't mind how you implement it, but they want these things to happen.
Okay.
In our case, we're creating a stack from scratch. So stacks in general have to have certain methods, and this interface acts as a laundry list so that it forces your class to implement them. And we'll see how it forces it to do that. Now, what are those methods? And that's sort of what we'll talk about here. I'm going to zoom in so that you're not distracted by the other stuff. But when you look at a stack in general, first of all, forget the stack, right? The idea is that data structures in general, what's a data structure from your understanding?
I don't know how to define it.
Okay, so don't worry about defining it. It's just anything that holds data, right? So if we look at a linked list, it holds data. A stack, it holds data. A queue holds data. All these different data structures, a tree, a binary tree, it holds data. But the difference is in how we delete items from a data structure, how we add an item to a data structure, and how we find an item in a data structure. And so if you look at a stack, if you really try to investigate how is data removed, how is it added, how is it found, that's going to be entirely different from how a queue works, right? A queue is different in terms of how we find, delete, remove, and so forth. And some ways of deleting, removing, or finding might be more efficient than other ones, right? So there might, and we'll talk about time complexity later, but just know that based on the data structure, you could have more efficient ways of removing and adding. And that's why we choose different data structures. So they all hold data. So the stack is going to hold data. And some of the methods that you might see in a stack, they call it push, pop, and peek. These are names that by convention are for the stack. Push just means to add an item. Pop just means to remove an item. Peek just means to look at an item in the stack at the top. Okay, so just because there are different names here doesn't necessarily mean like, you know, we're changing it up. We're still removing, we're still adding. So if you look at a definition for a stack data structure, and let's say you were to search up methods, I don't know if you can see this page, can you?
Yeah.
Yeah, so you can see that the stack data structure has three main methods. It has push, pop, and peek. And you know, this is a description of that, but really it's just removing. So if you look at a queue data structure methods, right? You can see that they just have different names. So if we look at the implementation here, they call it remove data or insert into the queue, but really it's the same thing. If we look at a stack implementation in terms of the data structure, they generally when they create the stack, they'll have they'll have push, pop, and some other methods here. So they're all doing the same thing. They're all removing items and adding items. The difference is that the names are different. So here the stack follows an order here, which we talked about the other day, last in, first out. And the main idea is that if you think of a stack, and the best way probably is to think of it in terms of books that are stacked on each other. The rule is that if you have, like, let's say a stack of anything, in this case, a stack of books, you can't really remove. So when you choose to remove an item from this stack or remove a book from this stack, you're forced to remove the first one, the first one on the top, right? So the last book that you added to the pile is the first book that you remove from the top. Does that make sense?
Yes.
So you can't remove books from the middle here. That's not going to be possible. The last one that you put is the first one out. Okay. And we sort of see that here, right? He added C, he pushed C onto the stack, and then he popped C, and that last one in, which is C, is going to be the first one out. We're forced to do that. We're forced to do that. And so these are the three main things you want to remember for a stack. And usually, when we talk about arrays, we see them in this linear way, sort of horizontal. But usually when people draw out a stack or they try to explain the stack, they're going to draw it upright in this way where it's vertical instead, because that just correlates to what we know better about stacks in an everyday sense. So it's a little easier. The indice is still going to remain the same. It's still going to start from 0 and work its way up. And there's another variable here that people generally include in the stack data structure. It's called top. Now, the function of top, and they're always going to call it top. By convention, they call it top. And the function of top is that it's always going to point to the top, the latest element on the stack, the top of the stack. So if I had, let's say, 3 items here, top, if you were to try to print out what top is, what item is at top, it would be this guy, right? So top keeps track of where we are in the stack. Now, top doesn't mean the last slot. That's not what top means. Top is not the last slot. Top is just where the last item is. Does that sort of make sense?
Yes.
Okay, so that's how it's going to work. Is I'm going to convey some facts, and then if we agree on them, we'll move forward.
Okay.
So that's it for now, which means our interface has to have push, pop, and peek. And the pattern that we're going to follow here is we're going to first do this with the int data type in just integers, and then we're going to make the necessary changes to make it generic, and we'll talk about what that means. So again, method headers. I want a push function. I want a push function, and it's going to be public. I'm not going to return anything. It's going to be void because I'm just adding an item. I'm not really doing anything. I'm just adding an item. I'm going to call it push, and it's going to be, I'm going to accept an item. This is all I have to do for this. So I don't have the braces. I'm not implementing it. All I'm doing is I'm just noting down what I want my class to have. That's it. I also mentioned that I wanted pop, right? So when it comes to pop, I'm just removing. So I'm just going to write pop, and I'm not going to return anything. It's just going to be public void pop, and that's it. The peek, what peek is going to do is it's going to say peek is actually going to return the item at the top. Okay, so whatever top, remember that variable that we talked about that's always tracking the last element that you put in, whatever top is pointing to, it's going to throw that to, it's going to return it. So public int, I'm actually returning something now, and I'm going to call it peek. Okay, so again, a laundry list of stuff. I could also have a toString, right? Public, or maybe I'll leave that out, and I'll talk about why. ToStrings, by default, every object has a toString. But for now, this is sufficient. Okay, so this is our interface. Now, remember what I said about interfaces will force your class to have these methods. Let's see how that forcing process works. So I'm going to create a class this time. It's not going to be an interface. It's going to be a class. And this class I'm going to call array-based stack. Okay, it's going to be called array-based stack. Now, why I say array-based is sometimes you could also have something called nodes, where your stack is made of nodes and not an array. And in this case here, I'm going to make it it's going to be underpinned by an array. So I'm calling it an array-based stack. And that's really the difference is that the interface will tell you what you need, but when you implement it, you could do it with nodes. You could do it with arrays. So that can change. Your interface won't. And if your interface is generic, and we'll talk about that. Don't worry about that. But for now, just know that my stack is array-based. Now, the thing is that how do I connect this class to this interface? And the idea is that if you just write this implements stack interface here, now these two are tied together via contract. So this array-based stack and this stack interface are now tied together. Now my interface is telling this class that it needs to have the methods that I noted down in the interface, because that's the rule. And so if there's a slight underline here under array-based stack, and you can see what it says. It says add the unimplemented methods. Add the methods that were in the stack interface. So if I click that, it will auto-generate all the methods that it knows I need. It's going to auto-generate push. It's going to auto-generate pop. It's going to auto-generate peek in the same way that I mentioned them here. So if I choose to do this, if I choose to remove even one, it'll be a problem because I need to have them all. I need to have them all. So I can't, so I'm forced to, right? I'm forced to. If computer science says that a stack must have push, pop, and peek, it's going to have push, pop, and peek. Okay. Now, these are only the methods. Do you remember the other two components that we noted down in a class? What other two things did we say are in classes in general?
The constructor.
Constructor, right.
And the attributes, right?
Attributes, exactly. So constructor and attributes. So I mentioned this one variable, and it's a type int. It's going to be called top. Do you remember what top does? It tracks where we are.
Yeah, it's the index of the item at the top, right?
Exactly. It's the index of the item at the top, not the last slot, but just the item at the top. Now I'm going to also create an array. I'm going to call it stack, and And that'll be it for now. I'll make it private. Okay, so this is my stack. This is my array-based stack. I'm going to have a default capacity. So again, private, int final, and so the convention is that variables that don't change, let's see, private final. So it's not private int final, it's private final int. So the convention is that if you're introducing a variable that's not going to change at all, you capitalize it so that it's just sort of an indication that this is a variable that won't change, and you use the final keyword, so that even if you want to change it later, it'll throw an error and it's not going to let you change it. So I'm just having this as a default capacity in my constructor, and I'll ask you something too. I'll say array-based stack, because remember, the name of the constructor has to match the name of the class. Hopefully I'm screen sharing this. And for now, the top variable is defaulted at -1. So remember how I started off here, and this is by convention. Every stack will have a top variable, and it will initially start at -1. Why is that the case? Because if we started at 0, if top is 0, well, that means it's not empty, right? There's actually an element there.
Right.
So we always started off at -1. So we say this dot top, or you could just say top is -1. Now, as far as the array is concerned, as far as the array is concerned, you can just say, this dot stack, or stack equals new int of the default capacity, right? That's the size. And again, maybe I'll add this here, public static, and public static void main, an argument of strings, right? And again, remember what I said, that if you have an array, you can do like a single declaration like this in one line, but also you can break it up, right?
Right.
You can also break it up, and that's what we're doing. So this part here is just declaring. This part here is initializing, right? And another thing is, when you do this, what happens is you actually create an array of size 4, but those elements are all going to be defaulted to 0. So if you ever wondered what happens when you do that, if you printed out this array right now, you would just have 4 zeros, and we'll sort of see that becomes important for understanding how the stack works as well, is that the fact that when you declare the array, you're essentially going to have all the slots you want, but the exception is that they're all going to be zeros, right? So array of I. And if I run this program here, you can see that I just have 4 zeros, right? So whenever you do that, you generate zeros. Okay. Now, how would you code an overloaded constructor that lets you pass in the size? Like for now, I haven't given them an option. How would you do that?
Right. I would do public array-based stack,
Mm-hmm.
and then I would do int. I guess I'll call it like. I guess I'll just call it size.
Okay.
And then I would do this dot stack equals new int, and then the size that we pass in.
Exactly. So we're kind of giving them both options here, right?
Right.
And then of course we'll add that in. That's not going to change. So we have both of our overloaded constructors, and so everything so far we're on the same page, right? The interface just listing off what we need for our stack, and then we have our attributes here. By convention, we have top, and we have a default variable. We don't need one, but what would the size be for the default constructor if we didn't introduce this default capacity variable, right? We need to pass in something here. We could just say 10, right? We could just say 10, remove that entirely, right? So there are options here. But having it up here is a little better. Because what if I want to use the default capacity in multiple places? I can
Mm,
just change one variable and it'll change everywhere I used default capacity instead of going by hand and nitpicking at it. We're talking, so two main methods here, push and pop. We're going to talk about push. I'm going to convey some facts. You tell me if you agree with them. And if you agree with all of them, then we'll be in good shape. So I'm going to go back to Figma here. We're going to go back to Figma. This is all understood. We've processed all of this.
mm-hmm.
This is, so we have about 3 facts here before we get into the push method. If you agree with all of them, then the push method is yours. So the first fact is, this is how you, so you know that this is how you declare an array.
Yes.
Now, we talked about the fact that when you do that, if I put in 5, I generate, 5 zeros.
Mm.
And then if I printed this out, if I printed array.length, length is a property, it's an attribute on an array object. Okay, so if I do array.length, what does that give me? It gives me 5. Right, so what my main point is that when you do array.length, you get the number of slots you have. You get the number of slots you have. So array.length is how many slots there are. Do you agree with fact 1?
Yes.
Okay, this is fact 2. Fact 2 says, and this is sort of a law, the highest index in an array is array.length minus 1. So what do I mean? I mean that if we have this, right, let's say, so 1, 2, 3, 4. If I do array.length, what do I get?
You get 4.
4. If I do array.length minus 1, I get 3, right?
Mm-hmm.
3 is the highest index. So array.length is 4, highest index is 3. So given an array, you can always find the highest index, right? Same idea for this one. If I do array.length, I get the number of slots, 1, 2, 3, 4, 5, 6. And the highest index is the length of the array minus 1. So that's the highest index. So do you agree with me on fact 2?
Yes.
Okay, so first fact, array.length, number of slots. Second fact, array.length minus 1, highest index. The fact 3, so now we're on fact 3. Top is a variable that tracks the index of the element at the top of the stack. We agreed on that one. Now, for an array called stack, I'm creating an array called stack just like we had back there. If I do stack.length minus 1, that is the highest index in the stack. You're with me on that, right?
Mm-hmm.
So if I do if top is less than stack.length minus 1, if that is true, then the stack is not full, right? So if I, if top is, let's say here, right, and let's remove these guys. So these elements are filled here, right? And this is where top is pointing to. Now, if this is a snapshot in time, and if I ask myself, is top less than 5? It's not full. It's not full. So if top is, so long as top is less than 5, less than the highest index, I'm in good shape. I can push an item. So you agree with me on fact 3?
Yes.
Okay, so top is less than stack.length minus 1. If that is true, then the stack is not full. You want to replace stack.length minus 1 in your head with just saying that this is the highest index. So you can just erase this and you can just call it highest index. That's what stack.length minus 1 gives you. It gives you the highest index. So you can just say top is less than the highest index, then it's not full. So the above is the same as saying top is less than the highest index possible, right? So that's the idea. So these 3 facts are key. So as long as this is this, if I put this in an if condition, this one here, and this is true, I know that it's not full, right? So those are the 3 facts, and we're all in agreement, right? Okay.
Yes.
Now we're going to talk about how to push. How do we push? And this is where, why they call it data structures and algorithms, because an algorithm is a series of steps you take to solve a problem. Our problem is here, how do we push? So we want to check. So the first step is to check if the stack is full, because obviously we don't want to push if it's not. If it is full. If it's not, then we move top up by one. Wherever it is, we move top up by one. Correction here, and put the item, right? Put the item where top refers to. So this is the idea, right? Add the item to the stack. How do you do that? You move top up by one, and then store the item where at wherever top is pointing to. So if I had, so we'll kind of see this, it's empty right now. So once I call the push function, it asks me, is top less than stack.length minus one? What is stack.length minus one?
The highest index.
Yeah, the highest index, which in this case is 2. So since this is true, I move top up by 1, right? I move top up by 1, so top refers to this. I move it up by 1, and then stack of top, right? So the array is called stack, and then of wherever top is pointing to will store the item. So it'll store the item here, right? Now if I come in again, it asks, is top less than stack.length minus 1? The answer is yes. So I move top up by 1, right? And then stack of top is the item, okay? If I come in again, is top less than stack.length minus 1? The answer is yes. So I move up by 1. Stack of top is equal to the item, right? Now I come back the last time. I ask myself, if top is less than stack.length minus 1. Well, it's not less than stack.length minus 1. It's equal to stack.length minus 1. That basically means that I'm not going to go inside this if statement. This basically means that I'm going to print cannot push on a full stack. So this method makes sense, the push method?
Yes.
Okay. So in the push method, we'll follow the pattern. We'll say that, if top is less than the stack.length minus 1, then we'll move top up. We'll move top up by 1. And what do we do then? We just take our stack, and whatever top is referring to will equal the item, right? That was the same as, let's see here, what's going on? Oh, it's like I'll have to break the meeting up because this is on the finite time one, which is fine. I'll merge the recordings, but that's the push method. The pop method, right? What about the pop method? So you're with me on the push method, right? Entirely?
Yes.
Okay. What am I missing here? Else. Right? Cannot push on an empty stack. That's what the idea is. What about the pop method? So I haven't wrote anything for the pop method because I wanted to leave that for you. Talk to me about the pop method. Remember, the pop method just removes an item. So how do you think that would work? What are all the considerations? Everything you know about push, try to see if you can reason out.
Yeah. Pop. Well, first we would check if top is greater than -1.
Okay.
And if it was, then we would return. Oh wait, are we returning anything with pop?
So that's a good question. That's why interfaces come in handy, because you already have defined what methods you want it to have. Pop doesn't return anything, right? We just remove. And this is a question for you. I mean, why don't I have to return anything? I mean, how do I know where to pop? I haven't given them a choice like where to pop. I mean, so how do I know where to pop?
Know where to pop.
Like, it's just a pop function, and I'm not giving them an option. Shouldn't I give them an option?
Well, since it's a stack, aren't we only able to remove things at the very top?
Exactly. It's a LIFO. It's a LIFO, right? And that's what we talked about. LIFO. Last in is the first out. You can't disobey that rule. That's the confine. So you're confined to that rule. So if yes, we remove, right? Remove item at the top of the stack, top of the stack, right?
Right.
And then if no, just tell them, right? That's the algorithm, right? That's the algorithm. Okay. So if top is greater than -1, so how would you implement that? How would you implement that?
I would do, well, okay. If it's greater than -1, let's say it was, we should not decrement it first, right?
Yeah, would it make sense to decrement it first? Yeah.
Right. Okay. So I would okay. So when we're removing something from this array, what do we do with it? We don't just replace it with a 0, do we?
We do, because remember
Oh,
what
we
I
do.
said before. Yeah, that's it. That's what I wanted you to come to the conclusion to, which you did. Remember the default values that were generated when we made an array, those were all zeros. So technically, an element not being there just means that it's a 0.
Oh, okay.
Okay. So yeah, you're right. Well, so what would that command look like?
So I would do stack at the index top,
Yeah,
would equal 0.
exactly.
And then I would decrement, right?
You'll decrement. That's the algorithm for the pop. You remove what's there, move it down, right? Also, of course, I'll just say that you cannot pop from an empty stack. Or yeah, you cannot pop from an empty stack because we want to make sure it's greater than -1. Now so you might see some of the implementations, they might say, oh, it must be greater than or equal to 0. This would work too, right? This would work too. But we'll go with what you said. Both of them will work fine. Now let's see this in action. So I'm gonna make a toString here. Okay, remember what those were. Do you remember what a toString was?
Right. It just returns a string that like represents your object, right?
Exactly. Now this is so crucial. Let's not overlook this one fact that we're about to face. This is crucial because this is what we were talking about last time and it got a little foggy. So I'm going to essentially I'm going to create a string here. This is my result, the string representation of an object. Jesus Christ. Okay, so it's a string representation of an object. I'm going to loop through the stack. So what do I do? Stack.length?
Yes.
Okay. And then result will equal what result was before plus stack of, this is just a basic array traversal. I don't have to go over this, do I?
No.
Okay. So and why is this giving me an error, John?
Oh, because we're not returning result.
Exactly. You have to return result. Okay. So for all practical purposes, this should work. So let's go to, let's create a main. I'm going to call it main here. And basically what I'm going to do is I'm going to say public static void main, an argument sprint, right? Now, this is the command. Remember how we created, like, let's say a person object, you said person p1 equals new person, right?
Right.
That's kind of what we did. Here, my object is called array-based stack. So I'll say array-based stack, my stack equals new array-based stack, right? And this is fine. Okay. So I'm going to do my stack dot push 5, because remember I'm dealing with integers here. Okay. 3, 2, 1, right? So we should be fine if I print out that toString back there. If I do my stack dot toString, it should just give me a string representation of the object. Now this is crucial. It's crucial to note what's happening. We're gonna let when it happens, we'll let it sit. And then I'll restart because I'm left with 2 minutes here on the Zoom timer, which means I have to migrate to my other account, which is Infinite Time. And then it'll give you an opportunity to think about it. So let's print this out. So you see what happens, right? I do get the 5, 3, 2, 1. I do get the 5, 3, 2, 1. But what else happens?
We get the empty values.
Yeah, we get the empty values because remember when we did the array-based stack, we did the toString, we iterated for the entire array, right? We iterated for, so let's say if I had done like 20, if I put in 20 as my default size, then what would I get?
We would get 5, 3, 2, 1 with like 15 zeros.
Exactly. So this is not what we want to do. What do you think the solution is here?
So with the for loop, we should check while I is less than would it be top?
Okay, again, perfect, right? Perfect. That is assumption number one. And before I do that, I'm going to make this look like a stack. There's something called an escape character in Java. If you do -n, it'll take you to the next line. So instead of all of this being printed out this way, they'll be stacked on top of each other because every time I do result, it'll take me to the next line. So you'll see that if I print it out like this, they're all stacked on each other, which is better, right? So what you said here, and again, just 1 minute here on the timer, but we'll do I is less than top. And this kind of works. I mean, it's a good guess, the solid guess, but what happens? We miss one. Miss one. Why do we miss one?
Because we didn't, since top is the highest index that we have a value at, we wanted to include top.
We want it so it should be inclusive, right?
Right.
And guess what? That solves our problem. 5, 3, 2, 1 without all the rest. So that's the idea. I'm going to wrap up here because we're short on time. I'll reboot another meeting. I'll merge these two together.
Cool.
So where were we here? We had just finished making the needed changes to the toString. And so, yeah, that was, again, what I'm really trying to convey is the difference in approach, right? So this was one option, right? Doing I is less than top, I is less than or equal to top. Another relationship might be, let me go back and load the Figma up here. Oh boy. So another thing might be, and this is sort of an assumption for now, and you might see this in other places, but if we have, let's say, and this is where the critical thinking comes in sort of sometimes, if we have, let's say, this element here, this element here, this element here, let's say top is here, and we know that, this is 0, 1, 2. We want to iterate 3 times. We want to iterate 3 times to get all those elements, right? But when we had done I is less than top, we didn't really catch it all, right? So we did equal to get that. Another relationship might be that if you iterate top plus 1 times, then you actually you get to what you want. So what I mean is that top is 2. We want to iterate 3 times. So wherever I am, if I take top and I add 1 to it, I can still get all the elements. So if I remove this, and again, just difference in approach, same idea. I still get everything I want, right? So top is, because top is offset by 1. So if I add that 1 back to it, I get all the elements that I want. So there you go. That's varying approaches. Someone could probably use a while loop here, right? We could say, you know what, screw the for loop. While top is less than or equal to, this was your condition, while top is, or we'll have to sort of create an index here called 0. While that index is less than or equal to top, do result equals what result was before plus, just that basic thing that we had, plus stack of what, top. Okay, and we'll have to move the index up by 1. Let's see if this works. So we get 1, 1, 1. Why do we get that? I'm printing stack of top. Result will equal what result? Oh, I think we're just doing the index. We'll forget that for now, for the sake of the recording. We'll revisit that later. But the purpose for this.
Oh, you know what?
Yeah. Oh, actually, yeah.
Because
One
yeah.
second. Why don't you explain this for, okay, top, stack of top.
Because shouldn't it be, since we're not decrementing or incrementing top,
it's always
we should return stack of index, right?
Right. It's always returning the same thing, and it keeps adding that on. There you go. Okay. So again, I'm insecure about confusing you like last time. But we'll revert back to what we had before, which is sort of the more intuitive approach. But what I want to say to you is that all for loops can be written as while loops. Okay, so you can take any for loop and actually change it to be a while loop, and you can take any you can't do that the other way around. Okay. All right. Let's play with this for a bit to make sure we're fine. If I do my stack dot, what I'm going to do here is I'm going to do pop. What should my output be? And these are questions you might see where they'll do this and they'll ask you, what's the output?
My stack dot pop. So pop. Oh, shouldn't it just be 5, 3, 2, 1? Or no, 5, 3, 2?
Yeah. What was your reasoning on that?
Because since a stack is LIFO or last in first out, the last value that we push needs to go.
Exactly. So 5, 3, 2, right? And we'll essentially do that more than we should. And it says you can't pop from an empty stack. Okay. So this is the basic idea, right? And we have a better understanding of stacks in general. So let's go ahead and look at stack implementations, in data structures. We'll just sort of, shop around and see how other people did things, right? And you'll see that the same concept, different implementation. Okay, this is another language here. This is C. So we'll do it with Java, and maybe we'll look at some images of people implementing it. Perhaps, maybe not. Let's see some implementations. So you can see their push method looks slightly different than ours. Their pop method, is the top. So for their pop method, they were like, hey, is it equal to -1? Is it, if it's not, everything else is fine. Or if it is equal to -1, then we'll say that, it's you can't do this. It's a stack underflow. You're beneath the bounds of the stack. Otherwise, they'll let you do it. What's going on here? Top minus, what's going on here? So the idea is, and this is why it's beneficial to look at people do things. You could do this. You could do this, what we did here, but also you could say top minus minus. Let's see where this was. You could say top minus minus like that. So what that does is it executes this without looking at the negative, and then it will do the negative after. Okay. This is called a post decrement. A post decrement. They call it post decrement because after this line is executed, it's not going to decrement it as soon as it's executed. It'll decrement post. after. So
Oh,
okay, so post decrement, pre-decrement, these are all important terms. Post decrement in Java, right? If the decrement operator, which is what that negative is mentioned after the variable, then it is called a post decrement operator, in which case it will do what you want. It'll decrement after you run the program, right? Or directly after that line executes. And again, it still works as it should. We have no errors. And if we remove the excess pop statements, you can see that we're fine in that regard too, right?
Mhm.
We popped twice, so we removed 2 of them. That's essentially it for that part of it. We're going to talk about generics now. Okay, we're going to talk about generics. And we're going to use exactly what we have here. We're just going to make it generic. First of all, what's your current understanding of generics?
So if okay, if we create a generic class, right? Is that what you call it?
Yeah, we do call it that. That's exactly what we call it.
We can we like in this example, we've used integers for our stacks data type, but a generic class would allow us to use multiple data types without having to create multiple classes, right?
It really would. It really would. That's exactly what it is. If I sort of remove this for a bit, and this is again, I'm just guessing. S1 equals new stack. Let me see if it lets me. So Java provides a stack for us, and it's in the utility. So java.util.stack. It's importing. It goes to the Java library, goes to the utility class. So there are a bunch of utilities there. One of them being the stack. This is their inbuilt stuff. Now you can see that I can specify, it lets me specify in these angle brackets whether I want it to be integer or whether I want it to be string. So I could have a stack of strings, I could have a stack of integers. So we want to recreate, right? We want to allow users to generically use any type of data. That's why it's generic. It's in the general sense, right?
Right.
So we're trying to do this with what we have, right? Not, of course, they have it already, but for the purpose of learning, we're trying to do this as well. And this is hugely important. Let's start from where we started originally, which was when we were doing the stack interface. So I'm pushing an item of okay, well, first and foremost, if you want to make a class generic, go to your class header, add the angle brackets. Remember those angle brackets that I just used in the main method? Right. Add them and put T here. Again, you don't have to put T. You could put M, K, or you could put anything. But I'm putting T because that is, yet again, the convention that we use. T, they like to say T stands for type, any type, type T. They'll call it type T a lot, class of type T. So this tells Java that your class is now generic. And wherever I'm using ints, now I have to change that. So if I was pushing an item, now I'm only going to push items of type T. They get to decide what that T is. I'm just putting that as a placeholder there for me to tell my program that they can do anything with it. They can put type T. Okay.
Right.
Peak. What would you change peak? How would you change peak?
I would say public T peak.
T, right? Because I'm returning, right? I'm returning a generic type now. It could be a string. It could be an integer. I don't know. T catches them all. Okay.
Right.
Nothing to do with pop here. That's fine. Now in my array-based stack, so look at the errors I have. Learn from the errors. The first error is at the class level. Again, I want my array-based stack to be generic. So again, I introduce those angle brackets. I say it's type T now. Okay, it's type T now because I want my class to be generic. And it not only implements a stack interface, but it implements a generic stack interface, right? So those are the 2 changes that I had to make here at my class level. Now, of course, there are problems in the push because my stack interface, remember the interface tells you how you should have your methods. Here, my methods are generic. But in my array-based stack, they're not generic. They're using ints, right? That's not something I want. So let me start with my array here. I'm making my array not of type int, but of type t. Okay.
Right.
Now the slight difference here is that when you declare a generic array, and this is the way we do it, we don't use type, we don't say t here, or we don't say new t. T is a placeholder. It's not a legitimate class. It's just a placeholder. So I can't just do t here. I do object. Object will catch every single. So if I do this dot stack equals new object of default capacity, that will catch all the different types of objects I could have in an array. And I do something called I typecast it. I force it to be an array of type t. Okay. So those are sort of the steps there that, okay, I'm creating an array. It will be of any type of object. And then I typecast it to be the type of object I want. Typecasting means you force a data type to be a certain way. So I say t, an array of type t, and that's the idea. So I have now an array-based stack. I do the same change down here where I say, okay, well, I'm going to have an array of type object, but it will be of type t. Okay. And now I have I still have errors, obviously, because remember my push method doesn't need to be int item, it needs to be t item, right? Because for the generic type. And then everything else is fine with this push guy. Pop, what's the problem with pop? The problem with pop is that saying stack, what's the problem with pop?
So with pop, right, we can't, let's say we pass in a string, then it would have to be, I forgot, either null or an empty string.
Yeah. So it'd be null, right?
Okay.
Null takes care of all of them. So with integers, yeah, if with integers and you just remove, if you make it 0, it'll be like, oh, okay, there's no integer there. Or you make it -1, it'll be like, oh, there's no integer there. Here for objects, it's either null or there's an object there.
Okay.
In our case, we'll just say null. And that fixes it. Peek is something you're going to tell me how to do. And again, I don't want it to be int, right? It's going to be t, type t. Tell me, so I'm going to write the description here. You tell me how to code that. Okay. Returns the item at the top of the stack if possible. Let's talk about that. Tell me, what are your thoughts? It doesn't have to be an answer. It could be an answer if you want it to be.
So the first condition we should check is if top is greater than -1, because that means it's actually, there's an actual value in the stack, at least one.
Yeah.
And then if there is, we would return, would we just return, what was our stack? Yeah, just stack at the index. Yeah, stack at top, right?
Stack at top, yeah. Yeah. That's the idea, by the way. Right, we're not doing anything with top, are we?
No,
right.
We're just peeking. We're not moving anything around.
Exactly. So what's the problem here?
So problem is, let me think. Is it because we have to, well, okay, this could be totally wrong, but we have to kind of return something outside of the conditional statements?
Yes. Do you know what? That's exactly the answer, and it's not wrong. Like if you say, this is the idea, Don. If you say that me returning something is contingent on another thing, what if that thing doesn't happen? Then I never return it?
Right.
Right? But my method says I must. So what you do here is you say, okay, well, this is my t of type t. Like I could say int result. I'll give it a default value, but it's type t. So I'll say t result is equal to null for now. And if it's possible to peek, in which case top is greater than -1, then I'll just say that the result is stack of top. Otherwise, I'll say cannot peek on an empty stack. It'll always be null. I'll just return result. Does that make sense?
Yes.
Okay. So I start off by assuming it's null. And if there are elements there available for me, then I'll set result equal to stack of top. Otherwise, I say you can't print on an empty stack. In any case, I return a result. So I must return result. It should not be contingent on conditionals, right? If your method says you must, you must. So you have to take that into account. Let's try to test this out. Let's try to test this out. So you tell me what the output is here.
Okay, so it'd be last in, first out. So we would, first of all, it would return 2. But I don't know where that 2 would go. And then it would print 5, 3, 2.
Yeah, exactly. So you don't know where that 2 would go, which means that we wouldn't really print 2 out, right?
Right.
Because the peek method returns something, right? So we actually have to print what that returned thing is, right? Stack dot, is that what you were referring to?
Yeah.
Okay, stack dot peek. So I just printed out the 2, and then it just printed out 5, 3, 2, right?
Right.
Does that make sense?
Yes.
Okay. And you can see here that if I now choose to make this of type string, I can do that, right? I can say type string here. Do you see how that works? Now I would be forced to push string objects, right? So, John and so forth, and my stack dot push Terry, right? So I'm allowed to do this now, and I can create an entirely different I can generate an entirely different guy here and have it of type integer, and that's fine, right? And that's fine, integer. And instead of pushing John and so forth, I instead push 2, and this is I'm getting an error because they have to be different stacks, right? And so this is the benefit of creating a generic class, is because you can create different types of, just like we had seen before, and so much so that you can create objects yourself and put them into your stack. So I'm going to create a private age, private string name. Okay, what did I say they must have, right? They must have a constructor, and I'll overload that from the get-go. I'll say that you have a name, and I'll say that you have an age, and I'll say that again, what we were saying before, I'm just creating a generic, not a generic, but just a watered down person. And remember what I said, you could have a set name, and that basically just takes in, remember what that takes in, it has to take in something. And then we tie what's local to what's global, right? And then we have virtually the same exact thing for the set age, right? And except instead of using strings now, we use the age, and we say this dot age is equal to age. What am I missing?
The getters.
The getters, right? The getters. So the getters, do they return anything?
Yeah.
Return this dot age. So I actually have to not make that void this time, right? I have to make that int, and then public string, right?
Right.
I'm going to create a toString here just to demonstrate my point. Okay, and this toString is going to come in handy. You'll see where. I'm just going to return an empty string here that just says name, and it's going to be this dot name. Basic class, right? Just the generic stuff. And I don't mean generic in that sense.
Right.
And now I can actually I can create people before. I can say person p1 equals new person. Right. And then I can actually just load people into like my data type is now people. So this brings up a fact that and this isn't going to work. I have to add in P1 and P2 now, right?
Right.
So this brings me to one fact at the very end of this, that when you're creating your own objects, you're actually creating your own data types. That's what you want to remember. And it takes a while for an instructor to get to that point, and you can only really see it here. I was able to load integers, I was able to load strings. Now I'm actually able to load my own objects. But objects are, in fact, your own data type. In fact, in some courses, they'll sometimes even leave out the word object. They'll say how to create your own data types. That's the idea. Okay. Now I'm going to go back to this will be my last point. I'll go back to the toString method. Now each stack of I is what? A person, right? Each of the stack of I, like any stack of I, stack of 0, stack of 1, stack of 2, they're just people. And
right.
each person has toString on it, right? So if I go back here and I can say toString, I call each person's toString, right? And when I go back to main here and I print this out, you can see I get their toStrings. Does that make sense? Okay. What if I didn't have that? What if I didn't have that? Seems to still work because the toString, I believe, is a default part of it. Like toStrings are generated by default. And I'll probably look into a little more about what those details are behind the scenes. But let me see here if I...
Oh yeah, I heard that toString, if you have a toString method, similarly to like how if you like printed out an object, it automatically calls the toString method
on the class.
If you concatenate the object with literally anything, it also calls it toString method.
toString method, right. Yeah, I mean, these details are important, and sometimes it's easy to break down, but yeah, it's really the devil is in the details of these things, right? But yeah, so again, that was the main idea. I might have to head out here, but we'll cover we'll keep this file as is, and we'll cover something called exceptions. You creating your own exceptions, which is important. And that shouldn't take too long, but we'll cover that at a later time. But for now, this is the picture that we've painted. We started off with a stack using object-oriented programming, what we learned before, with just integers. And then before we even looked at the class, we looked at the stack interface and interface in general. Remember what that interface does? It contractually binds a class that implements it. And then we were able to mess around with it. Maybe before I go, I'll give you an exercise here. Can you create a class in the array-based stack called double pop, where if you call the double pop method, it will pop 2 elements instead of just 1. Let's see if we can do that. Can you do that here?
Yes. So yeah, I would do public void double pop, and we're not taking any values in as parameters. Okay. And then I would do if and then what should I do? if it's greater than, okay, if top is greater than 0, I guess,
Okay.
I would then set stack at index top and index stack at index top equals null, and then stack at index top minus 1 equals null as well.
Stack at index top. What's your next line here on 68?
Stack at index top minus 1. Oh, or I guess we could decrement and then just do the same thing.
Okay.
Yeah, let's just do top decremented and then repeat that again.
Repeat that again. Okay.
Yeah. And then else, then yeah, we can't really do that.
So I'll push about. So I'll have to go through quite a bit of work to create multiple people. So I'm going to change the integer for now. And I'll just do 3 and 2, and maybe I'll duplicate that, but change a few things. Three, four, 2, 4, 1. Okay, so if I do, what are we expecting when we do double top?
We would do, or we would get 3, 2, right?
Yeah. Okay, 3, 2. So stack of top equals null, and then so again, I in the mind of a genius, we find our own neglected thoughts. So we'll try to do let's try to do what you were saying before as well. Equals null. So at this point, we did stack of top is null, and we did stack of top minus 1 is null. So they're both null. So what do you think you could do now?
I would just do top and minus equals 2. Yeah.
This is called a shorthand operator, which comes in quite handy. Let's see if this works here. 3, 2, right? So, if you have a little burst of inspiration there, follow it through and see where your logic takes you, because that's really the whole craft, right?
Right.
So I'll let you go on that, and we'll cover exceptions at a later time when I have a little more time. And I'll send you these files. I'll bundle them up. I'll send you the file. I'll merge the videos. I'll post it. That can be a standing resource. Okay.
Cool.
All right. Awesome.
Cool.
Nice work.
Thank you, Ron.
Yep. I'll see you later.
Peace out, bro.